This is assignment number 4, question number 1, right off the bat. We're going to go over nano signals. I have my code here. I'm just going to show it to you guys. So I was watching this. This is my code over here. And basically, um, you can go through it. We have the we exit status, the WIF exited, WIF signaled. We have everything here. Now I'm going to get into explaining this. Going to first close this thing up. Okay. So then we're going to compile this thing now. I have all the prompts and commands ready because I don't want the video to be too long and TAs were complaining about videos getting long, which is completely fair. Okay, so this is how the thing, this is how the output works. So question 1 is basically demonstrating the process relationship and waiting with the macros. Basically, the parent for 2 children. Child 1 sleeps, so it'll be orphaned after the parent's exits. Child 2 exits immediately with code 9. And then basically, the parent waits only for child 2 using wait PID. It prints its exit status, then it terminates. And then after when child 1 wakes up, its PPID becomes 1, basically showing it's been adopted by INIT. So yeah, that's pretty much it for this question. And 2 for assignment 4. I'm going to start the script right here. And then we do have to create 2 source files, starting with nano. I just may do nothing because it's literally all it's doing is just sits on idles and wait for the signals. Okay, and then we have nano. This is the actual tester file. I have my code ready that I did. Now we have that here. Okay, so now we can compile both of them, starting with the first one. Perfect. Compile the second one. Done. And just compile this guy. Okay. So basically, what's happening in this question is I'm basically demonstrating how the signal dispositions behave across the exec. I set up basically a custom SIGINT handler and a parent and ignore the SIG TFB. And then after forking the child execs do nothing. Now I like execs with the do nothing. And then now I get the SIG STP to the child because the SIG again persists across exec. So the child keeps running. Then I said SIGINT since handler is reset to default across exec. Then the child terminates by SIGINT. The parent confirms that using wait PID and then prints how the child ended. So then this is the expected output that we had for this. Oh, now moving on to question number 3 for systems programming for assignment number 4. Starting the script file right there. Now I'm going to create a source file called nano. And then I have my code, basically alarm. Basically, the child sleeps for an amount of seconds, and then it sends sig alarm to parent, and then parent catches it, and then prints ding. Pretty much all it is, pretty self-explanatory. Okay, now we're gonna compile and run this guy. Okay, so again, the alarm application is running. It's waiting for 5 seconds. So basically, what's happening here is that the parent installs a handler for sig alarm. The child sleeps for the user specified number of seconds and then sleeps sig alarm to its parent. The parent is paused waiting for that signal, and then when it does arrive, the handler basically prints ding, and then the program ends. Basically, this shows that the parent-child signaling and custom signal handling works. So yeah, the output is here, perfect alarm application running, waiting 5 seconds as I input 5 seconds, and then ding, and then done, and that should be it. Should exit the script file. Okay. Hello. So this is question 4 for assignment 4. Start the scripting, recording. Now I'm gonna start off by creating the source file. This one's gonna be called multi-signal. And then I have my code here, basically the one user-defined handler installed for both the SIGINT and the SIGQuit. Yeah, we'll get more into it. So then also with that, basically when invoked, it prints the signal number and then it verifies the signal handler can handle both content. Now we're going to be running this code, making sure everything pilot first. Then we shall run it. Okay, so basically this is what's happening here. You can see that everything is working perfectly, and I can even press some things here. I pressed Control C, and I pressed, yeah. So basically this thing is working. So what's happening for this question is I installed one handler for both the SIG and the SIG quit, and then when I press Control C, that's SIG int 2, and the handler prints a signal number. When I press Control plus 1 second. When I press Control, where we go? Yeah. And when I press Control and I press this guy, then I did SIG minus and then Control plus. Yeah. So that this shows basically the same handler runs again and then prints the three. So this basically shows that a single user defined handler can service multiple different signals exactly as required in this program. And then yeah, that basically is for this film. Yeah, that's basically it.